Hello, welcome to Leeds PHP. It's September, and thank you for joining us. We'll start off with some meetup news. If you want to go on to the next slide. So first thing, we're welcoming Irene into the leadership team. Irene joined us last week to give us a talk and is now joining us as part of the organizational team. So would you like to introduce yourself?
Hi, everyone. Really nice to be part of the team. I'm Irene. I'm a software engineer. I'm interested in all things tech, development. I've got special interest in machine learning and AI. But yeah, really nice to be here.
Yeah, so thank you for joining us, Irene. And if anyone else would like to ever get involved in any part of the organization of this meetup, let me know. We're always after new people to do it, but it's always good to have new people on, and it's great to have Irene with us. So I'm going to actually hand over to Irene now to take over the rest of the introduction. So yeah, take it away.
So this is the schedule for tonight. We're going to start off with an introduction to Symfony UX with Titouan. Then we're going to have a short break, 5 minutes break, and then we're going to go to quantum key distribution with Panagiotis. At the end of the last talk, we'll just stick around for a chat if you've got any questions, anything like that, any interesting thing that you'd like to discuss. Then at 20:15-ish, we'll be doing that. We have Big Orange Art as our platform today, and we're very grateful for them allowing us to use their platform. And they're a company that supports and promotes positive well-being and mental health within remote working communities. And this is our Slack channel. If you'd like to join, the link is here, but then Hugh will also put it in the comments so that you don't have to read it out. You can just copy it from there. So that is everything. I think we're gonna get started with our first talk.
Hey.
Hey, Titouan, how are you doing?
Great, and you?
Very good. Ready to get started?
Yes, I am.
Cool.
Nice to meet you, everyone. So I don't know if I can know how many of you there are, but I'm not sure I have the information. It's fine. I'm really glad to be here. So as you may notice from my accent, I'm actually from France. So I'm currently in Paris. It's kind of nice to be able to do such kind of things online. Like the idea. So today I'm here to talk about Symfony UX, which is a tool, a component you may have heard of lately, especially last year. But I would like to give you some ideas about it. So as I was saying, I'm Titouan Galopin, so I have no, as I was mentioning earlier to Irene and the team, my name is difficult to pronounce, so that's fine. Don't worry about that. I'm working on Symfony Insight, so I'm working at the Symfony company. We are the company that's behind the framework, and we build products around it. So I'm building a code analysis tool, which is called Insight. And I'm also a part of the core team of Symfony, so the community, as the UX initiative lead. So that's exactly what I'm going to talk about today. So the aim of this talk is a bit of a challenge. The aim is to talk about Symfony UX and to give you an idea of what it is and how to use it actually in under 30 minutes. So ideally in under 25, I'm not sure I'm going to be able to do that. We'll see. But if I get a little bit longer, it's going to be fine. So let's start by the beginning. As you probably know, nowadays two main ways of building web applications. So either you can think about a web application in a traditional way, so an HTML built on the server, JS, so JavaScript adding on top of this HTML, and basing most of our code around HTTP, HTML, and browser standards. So basically building something that dumps HTML so that the browser can use it. So that's kind of traditional. It's Symfony, Drupal, Ruby on Rails, many other platforms. It's how the web was built originally. Or we can actually build something quite alternative to this, which gained a lot of tractions in the latest years, which is called single-page applications. So a single-page app is basically using the same foundation, but putting much more focus on the JavaScript side, so that we can have advanced logic on the client side. So for instance, we can have much more interactive applications, much more client-side validation, sessions handling, and a lot of similar things. So these applications are powerful in the sense that they provide a more advanced user experience. You can build something that better fit your domain, better fit your needs with single-page applications. But at the same time, you usually need to re-implement a lot of things. So usually you need to re-implement the history, the sessions, authentications, and a lot of other features like this that are usually provided by browsers. So I would like to discuss about these kind of applications, these types of applications, because I think that there is an opportunity here to do something interesting. And my reasoning is single-page applications are amazing to build reactive applications. So if you take, as an example, React or Vue or Angular, nowadays we use a lot of these tools to build applications so that when you click on a button, you have a loader. When you upload a file, you have a progress bar. When you click on a page, you have no refresh going on in the browser. You have a loader inside the frame that actually updated. So you have a lot of concepts like this, which are very reactive and very intuitive. So it's actually very nice to use if it's well done. That's another topic. It can be very wrongly done, but when it's well done, it's very nice to use. But the problem is, because we add these kind of functionalities, it usually takes more time to build such applications. So take, for instance, a good example of this would be, for instance, an application admin panel. If you have an admin panel that's based on the single page app, you have to have all the checks that you would do on the back end on the front end as well, because the front end, the client side, now needs to know what each person is able to do, what each role is able to do, meaning that you have to duplicate code both in the back end and in the front end. That's exactly the same for sessions, that's exactly the same for the history, that's exactly the same for many other features, URLs, etc., meaning that it takes a bit more time, at least, to build such applications. So the aim of Symfony UX is to say, okay, single-page applications are great. They provide nice UX, the nice user experience. But they do so by introducing a lot of concepts that are not necessarily linked to user experience. So having the ability to check validation, form validation on the client side is not necessarily linked to have a single page application. You do not need React to do this. Or if you need React, you don't need to have a full-blown single page application with dedicated URLs and everything. So the aim of Symfony UX is to try to find a middle ground in which we could try to have the advantages of traditional applications. So it's easier to develop, it's easier to test because you don't have to have any JavaScript engine, it's easier to work with because you can have a single team working on mostly PHP with a little bit of JavaScript where it makes sense, etc. So traditional applications are really great for that, for productivity, for testing, for ease of development. And at the same time, single page applications are great for users, basically, if they are done well. The aim of Symfony UX is to try to find how we could balance these two things. So to do so, let's talk about what's behind the scene. So there are two main components in Symfony UX. The first one is Webpack and everything related to Webpack. So the building process of your project, and the other thing is stimulus. And that's actually the most important thing we are going to talk about today. So let's dive into Webpack first. Let's imagine we have a Symfony application, a traditional normal Symfony application. To create such an application, which could use Symfony new demo full, for instance, if we want to have the full application. And basically that would create an example, Symfony example application. That's fine. We can work with that. And that's normal. That's PHP. That's Twig. So if you are comfortable with Twig, that's basically a templating engine. It's quite normal PHP, quite normal HTML in a sense. What would we do if we wanted to add interactivity? So let's imagine that if in this application, we would like for comments on the blog post to be added live to the platform, so that when we send the form of the blog post comment, it doesn't reload the page. It actually sends the comment as an AJAX call and display it below the form. That's a tiny little example of an interactivity. But the problem is, if we want to do this, nowadays, we kind of feel like we have to add React or Angular or Vue, because most of the JavaScript ecosystem is built around these tools. So it feels a bit like we are going to add a huge project, a huge secondary project into our first project, just because we want to add interactivity and add new nice UX user experience in some places. Instead, we could try to use Symfony UX. We could also use JavaScript files manually. That's another alternative. So let's not forget that JavaScript is actually a good language as well. We could do this. But the problem is you don't profit from libraries if you do so. You don't profit from the ecosystem of JavaScript if you do so. So the principle of Symfony UX is to connect three elements together. Webpack to build the application. Webpack Encore is a wrapper of Webpack that integrates with Symfony. So by using Webpack Encore, we are integrating Symfony and Webpack. And Stimulus is the JavaScript framework we are going to use. So the idea of Webpack, if you never used it, is quite straightforward. In JavaScript, it's better if you have a smaller file to transfer over the network, because JavaScript is on the client side, so you don't want to have a too heavy file to transfer to the client. So you want to have a small file, but having a small file makes it difficult to develop. So you use Webpack, for instance, to build your source files into a compiled, very small, minified file. So that's the idea of Webpack. It's a bundler. It takes many JavaScript files and combines them into a single one for performance. Webpack Encore is wrapping this to integrate in Symfony. So let's add both of them. When you add Webpack on Symfony, instead of adding Webpack as a JavaScript dependency, which would make sense, right? It's a JavaScript dependency. Instead of doing so, what we are going to do is that we are going to install the Webpack bundle. And that's where the first thing about Symfony UX is going to show. When we install the Webpack bundle, so the Symfony Webpack Encore bundle, what's happening here is that we have a few information displayed in addition to the normal composer behavior. So when we add the bundle, now we have here, as you may read, we have a bit of information about the fact that we now have yarn available. Well, it was available. We have a yarn file available, and we can install our JavaScript dependency and start developing on JavaScript. So when we run yarn install, yarn being the composer equivalent of in the JavaScript ecosystem, we just installed the actual Webpack and Webpack Encore libraries in JavaScript because Symfony UX, like Symfony Flex and UX, it's quite linked at this level. Symfony Flexed was integrated into Composer and added a few files in our project automatically so that this works. So now in our template, so for instance, in our base template, if you never use Twig, it's fine. It's very straightforward as well. It's a templating system. It allows us to build HTML based on variables and blocks and functions. So you probably know how templating system works. So basically here we are pointing to entry inside our Webpack library in configuration, meaning that the end files that I was talking about earlier, the compiled file that I was talking about earlier with Webpack, is actually named up here. So that's what we are referring to. So we are including the CSS and the JavaScript that's going to be created by Webpack. So now we have a traditional Symfony application, so with PHP, with everything that's what usual in a Symfony application. And in addition to this, we have a new directory inside of it. So this directory is called assets, and it contains a few interesting things here. So the first one is we have the usual elements of client-side code. So we have styling, CSS files. We have a first main entry point. So that's why what we were referring to when we were calling Encore script tags. So the main entry point is app.js here. And we have the files that are actually built by Webpack in public build because they are exposed publicly. So we have a structure that looks quite normal, except that we have two new ideas, two things that are a bit interesting in JavaScript. So in JavaScript, usually we do not use controllers. A controller is a concept that's well defined in backend code, whereas in JavaScript, we are usually more talking about components. A controller in JavaScript in Stimulus, as we are going to see afterwards, is kind of like a component in React or Vue, but it has way less responsibility. So that's what we are going to talk about. So this structure, which was built and configured automatically by using Webpack Encore and Flex and UX, allows us to use the next big thing we need to talk about. And this thing is using Stimulus. So the idea of Stimulus is that most JavaScript frameworks nowadays tries to take over your application. When you build a React application, for instance, a React project, it's going to create its own HTML and override whatever you created inside the actual HTML initially. So it won't care about what you built with Twig or with whatever templating engine you had before. So the idea of Stimulus is to not take over your application, meaning to augment your existing HTML with JavaScript, so that it's easier to add behavior on the DOM itself. So let's dive into it. As I was saying, the main concept of Stimulus is controllers. A Stimulus controller is basically a class, a JavaScript class, that is associated to a DOM node, an existing DOM node that you created in your backend. And when you connect them together, this class now is able to execute code that you write when the DOM node appears on the page, is clicked, is removed, is dragged and dropped, whatever you want. Basically, it's events of the DOM node. So let's take an example. If we take the structure we were talking about earlier, so assets, controllers, counter controllers.js. When we have this, we have the ability to create controllers for Stimulus. So let's imagine we create a counter controller.js file. Inside of it, we create a first class. We export it by default. So that's a notation for JavaScript if you're not used to, but it's quite straightforward. and it extends the class of stimulus, the controller of stimulus. So when we do this, we have a first class, and in this class, we have a first method called connect. Connect is a method that's going to be called by stimulus when a node appears on the page. So when a node is displayed on the page. So let's imagine here that we want to override the content of the node with some text, as you have clicked me 0 times. Now we are able to do so using the connect method. Note here that this dot element is a specific notation of stimulus. This dot element will be a reference to the DOM node on which we attach this controller. Now we have the code. We can compile it with Webpack and Webpack Encore. To do so, we can call yarn dev, which is defined in our package.json file. When we do so, Webpack took our controller, integrated it into the public build app.js file so that it can be used by our traditional web application. We can also use yarn dev server, which is a nice little tool that automatically builds the JavaScript you modify at live, so that you don't have to run yarn dev each time you change something. And once we develop the controller and build it using Webpack, we can then use it in our HTML. So, for instance, a good example of this would be inside any template in my application, I could use data-controller equals counter. So this counter name actually comes from the file name we used when we called counter-controller.js. So the name of the controller is defined as a convention in stimulus. When we have counter controller, it's data controller equals counter. Color dash picker stays color dash picker. And if you have a subdirectory, so post/editor, it becomes dash dash. So post dash dash editor. So by having this convention, we can refer to our controllers inside our assets directory. So now we have connected a DOM node that could be built by Twig. Here, as you can see, built on the server. It's built in Symfony in Twig. We connected this Twig DOM node to a bit of JavaScript that runs alongside it. And this JavaScript was included on our application by Webpack Encore, but it doesn't really matter anymore. So now we can react to some events. React being kind of a joke of a name. So as I was saying, connect is executed when the DOM node is entering the page. There is an important note here, though. Connect is executed when the DOM node either appears on the page at page load, as normal, but also in the future, if new nodes on your page appear, these nodes, if they have the data controller attribute configured to the right controller name, they will be catched as well by stimulus and execute the connect method. So stimulus kind of observe your DOM being modified all the time, so that a controller that creates another DOM node with a new controller could work well. So that's important because it means we can have interactive controllers that create each other and work with each other. Disconnect is executed when the DOM node leaves the page. Initialize is created only once, executed only once. So basically, if you have multiple usage of a controller inside a single page application, inside a single application, single page. So let's imagine, for instance, you have multiple counters inside your same Twig template. Connect will be called for each counter, whereas initialize will be called only once for all counters. And then you have all the methods inside of your controllers that can be extended using additional features. So there is a library which is called use-stimulus, which basically use the same idea of React hooks, which is a concept that is very interesting, and you may have to have a look at it, but I won't have time to explain it right now. But basically, the idea of use-stimulus is to add new methods on top of your controllers if you want to. So enable new methods like these. So for instance, by using this library, you could have a method to react to the fact that your node is hovered, or to react to the fact that your node is being dragged and dropped, or that your window is not focused anymore. So you may have a lot of methods like these that are actually easy to add in your stimulus controllers. And inside of these methods, then that's normal JavaScript. So that's normal JavaScript code. There is nothing very specific to stimulus. It's just a wiring, basically. So here, this .element, as I was saying, is pointing to the div, so the div DOM node we were talking about. So the data controller, so the node that has the data controller attribute on it. And you can do whatever you want with it. It's a DOM node, after all. So you can add new events, you can manipulate it, you can do a lot of stuff with it. So, for instance, it would create such a display. Now, there is another three other concepts which are important: targets, action, and values. I'm gonna go quite quickly over them, but basically, they all allow you to build more generic controllers. So the idea is that once you have built the first controller for your own application, you may be interested in actually reusing this controller in many places in your application. And it gives you a nice new possibility. What if I was able to create a controller for a specific part of my application, then another controller for another one, then another controller for another one, and these 4, 5, 6, 10, 20 controllers would then provide me a little bit of interactivity everywhere without overwhelming my project size, and still having the user experience I want. So that's the idea of stimulus, building such small controllers and using targets, actions, and values to try to make them generic in a way and help you reuse them across your application. So the principle of targets is to help you access DOM nodes that are inside your controller DOM node. So for instance, if you have a counter data controller attribute, you may want to access the number inside of it because you want to update it when it's actually clicked. So that you could do it in whatever way you want, so with a class, an ID, whatever. But it's easier to do it with a convention called targets. And in this example, I declare the target with a specific data controller data attribute notation, and then I'm able to access this number target inside my methods. So that's quite straightforward. We declare it, then we use it. Actions help reacting to certain events on my node, but instead of declaring these events in the controller, I would like to be able to declare them in the HTML. So here, for instance, instead of having this event this.element.add event listener inside my controller, which I could do, instead of having this, I'm going to use a data action attribute here in order to react to the click event. The reason why it's interesting is because now that I'm providing the ability to modify which element I want to click on, it means that the HTML has the responsibility to choose what is clickable, meaning it's more generic, because I can then, in another page, have a different way of building this. So in this case, on the click method, on the click event, I want to call the increment method on the counter controller. So that's another stimulus naming convention. It's a bit different. It's a bit a question of convention. It's up to stimulus. And then in our controller, we may have a method called increment that does what we need to do. In our case, incrementing the number inside the target. And when we do so, now we are able to click on the button, and when we click on the button, it increments. The last concept is values. So values is basically a way to store data on your DOM nodes. So the idea is either to expose data from your backend to Stimulus or to store a JavaScript state. So let's take as an example exposing data from the backend to Stimulus. Let's imagine we have such a controller in Symfony. So if you didn't use Symfony in the past, that's fine. We are only passing data from PHP to a template, to Twig. So default number here. When we pass this data to Twig, we then have a variable that we would like to pass to JavaScript. But we cannot really pass it easily, can we? With values, we can actually pass it quite easily. This notation here, data dash counter, so the controller name, dash default number being the value name, dash value equals some value, is used by Stimulus then to allow you to access the value itself from inside your methods. So here I passed a variable from PHP to some JavaScript. Here you can note that there is a declaration of this value. By having this declaration, I'm sure that this default number value will be a number. Not only this, so it actually defaults to 4. Not actually this, but by having a type, a value type, it means that we have the ability to use Stimulus to pass this value. So we can have a string, we can have a number, a Boolean, but we can also have an array or an object. Meaning that if we pass JSON encoded values into our data attributes, Stimulus will automatically JSON decode these values and provide them to us in our controllers. So that's very, very useful. And that's why in Symfony, we use the Twig helper to expose this data more easily. So for instance, here, the example we had before was data controller equals counter, data counter default number value equals default number. Instead of having this cumbersome notation, we introduced a Twig helper that basically does exactly the same thing. It generates the same HTML, but it's just easier to use. And because of this notation, we can then JSON encode whatever you give inside the values section, so that this is JSON encoded, and on the Stimulus side, automatically is JSON decoded, so you don't even have to think about parsing and encoding and everything. And the other reason why values could be useful is to store JavaScript state on DOM node. So I'm not going to focus on this because it's a little bit less useful, but it's a nice concept. The final thing I would like to talk about is, okay, now we know how to build controllers, we know how to use them in our application, we know that we have the ability to use targets, values, and everything. What about creating reusable controllers? What about shipping them in packages? Well, that's basically what Symfony UX is. So Symfony UX is basically making a bridge between Symfony, Stimulus, and Webpack, so that when you install a PHP package, this PHP package could ship some JavaScript to be executed as a Stimulus controller wherever it needs to. So let's take an example. These controllers will then be used in JavaScript, in your JavaScript. Let's take Symfony UX dropzone example. So that's an actual package of Symfony UX. When you install this package as PHP, Composer requires Symfony UX dropzone. When you install this, Symfony Flex, so the Composer plugin of Symfony, will detect that it contains some JavaScript and will advise you to run yarn install. Yarn install, well, -- force. Yarn install will take the JavaScript inside the package and put it inside your built Webpack file so that you can use it in your code. when you do so, it means that now your app.js file that is included in all your pages now contains the JavaScript of the package. Because of this, it also means that the package can rely on this JavaScript. So when here, for instance, we choose to switch from a file input to a drop zone input, what happens is the drop zone package will actually react to this, build some HTML around an input that looks nice and that works well. And this HTML will rely on the data controller attribute mentioning the required controller. So because this package is now able to input stuff inside Symfony and input stuff inside Stimulus, it's able to work on both client and front-end side. So internally, the package defined the Stimulus controller, and it used it when the type is rendered. And that's it. Because Symfony Flex registered the controller's file in the controllers.json file, by the way, that's an interesting thing to note. Symfony Webpack Encore embedded the package JavaScript, and then UX dropzone used it in its own template. So it provides both features at the same time. So it's possible now to build reusable package that ship both the front-end and back-end for Symfony. And that's exactly what Symfony UX is. Symfony UX is a series of packages that helps building reactive applications in specific parts of your page in order to combine the power of multiple stimulus controllers and build something more easier to maintain, easier to work with, while still having the SPA capabilities. There is one last thing I want to note about UX. In the UX and Stimulus ecosystem, there is one thing which is called Turbo. And Turbo is a package of Symfony UX as well. There is UX Turbo inside Symfony UX. It's a very nice library to augment even more your Symfony, your traditional applications to feel like an SPA, a single page app. So that's another topic I didn't mention here, but you may be very interested in looking at it if you want. Okay, thanks a lot. I have no idea how long I took. I'm sorry if I went way too long.
Thank you for that. That was very interesting. I've not come across that before, and I tend to work more in the back end, but that's possibly one of the best integrated or most clear integrations between the front end and back end with JavaScript that I've come across. I'm quite keen to work with that at some point. It looks very interesting.
I'm glad. I hope people will have a try at it because it's quite new actually. It was released last year in December, so yeah, it's quite new.
I don't think we've got any questions so far. If anyone does have any questions, please put them in the chat and we'll ask them. There'll be a few seconds delay between us getting them. So. Yeah, thanks for sharing that. That was very interesting.
Awesome.
It was a great talk.
Thanks a lot. My slides are already available on SpeakerDeck if people want to. So it was a bit quick because I didn't want to take too much time anyway. But if people want to go back to them, it's available online.
So someone's put in the chat, any idea what's next? I don't know if they're asking what the next talk is or what's next with the project, but on that concept, what is next with this?
Well, so it's a very wide question. So there are two main interesting topics on which I think we should work on. So the first one is UX Turbo, as I was mentioning, is going even further than what I discussed here. So UX Turbo is basically connecting, allowing a Symfony application, but it could work with any other application, allowing an application to be much more live, kind of, without having to implement things yourselves. So basically, what it does is it uses your HTML as an API and requests it sometimes when it makes sense. So you control everything, of course, but it's very alternative way of building applications that's based more like on frames and on having some events that triggers a re-rendering of some parts of your page and stuff like this. It's actually very nice. So that's something I think we should explore more. Another topic, which is much more straightforward, is that we need many packages. Like there are so many opportunity of creating packages there, because like we basically everything that needs to be both on the back end and the front end makes a lot of sense as a Symfony UX package, but also just having the ability to install a JavaScript package with Composer and it just works, that's really useful. Just this is really useful. So there are a lot of possibilities. There are a lot of nice ideas to have. Some people are working on UX maps, UX charts. Charts is actually something we should refactor. It's available. We should refactor it, I guess. There are many other ideas. So I'm quite I don't have enough time to do all of this.
Cool. Yeah. Thank you for that. Then I think we haven't got any other questions. So, and in the interest of time, I think we'll probably move on to the next talk. But thanks for joining us today. That was very interesting, and I'm interested to see what happens with that next. With these other bits as well. I'll definitely try and use it at some point.
I'd be happy to come back at some point to give you an update.
Yes.
I'd love that.
Awesome. Well, see you everyone then, and have a nice rest of an evening.
Yes, you too.
Thank you for joining us.
Cheers.
Okay, I think we'll bring the next speaker on now then. Do you want to do the introduction, Irene?
Yeah. So we have now Panagiotis with quantum key distribution. So hi Panos, how are you doing?
Hi, fine, and you?
I'm good. Yeah, can't wait for your talk.
Thanks a lot. Yes, I try to be not so mathematical and rigorous, just to be able everyone to grasp some concepts in my talk. So I'm ready to start. I don't know, okay.
Yeah, let's get going then in that case.
Yes, so I will talk about QKD, quantum key distribution, and as I said, try to explain some concepts. I will start first of all with a cryptographic scenario, a basic cryptographic scenario, where we have two parties, Alice and Bob, and there is a message that Alice wants to send to Bob, but she doesn't want anyone else to hear it, but only Bob. So what she's doing, she scrambles this message, applying a function, k, and sends this to Bob. And Bob knows how to unscramble this by applying another function, let's call it v, and decrypt actually the message. For this encryption and decryption steps, both of them need to have a password, a secret key, which we call it K, which should have been distributed from before they start this communication. But but this is not a secure thing to do. Only if you are in a clandestine meeting that like in a very dark room that that nobody else is near, and you can exchange this key with your partner that you need to communicate later. Or if you can build a private channel away from any public telecommunication infrastructure, which could be, very expensive to do. So currently, we use another method to exchange secret messages, which is the public key crypto systems. So here we have basically two keys. One is public, we call it E, and is used for encryption. And the other is for decryption, and is kept private by one of the parties. So what Alice is doing, she knows this key E, and she applies a function to scramble her message, so nobody else can read it, apart from Bob, that who can apply the G function to decrypt the message. So the problem now is that for anyone to really be able to decrypt the message, he or she should know this D. In principle, this D can be found, but in order to do that, you need a very fast computer. So the security of this public key crypto system is based on computational assumptions, which after some time that there might be a very high probability to have a fully functional quantum computer, these messages can be decrypted quite easily, and also in future times, also the messages that we have sent in past times using this kind of crypto systems, they are going to be also vulnerable to attacks. So what we can do now is one option is to further give more advantage to this kind of public crypto systems by actually using hardened mathematical problems, and I can show you in the next slide what I mean exactly. So basically, what I was saying before, the modern public key cryptography is based on algorithms like RSA, which uses difficult and complex mathematical problems with intractable instances by current technology. However, source algorithm can give significant advantage to track these kind of problems, jeopardizing the security of such crypto systems. So what now new technology has been suggested, we call it post-quantum cryptography, which can create this more powerful mathematical problems that cannot be easily solved by even by a quantum computer. However, because quantum computers are specialized at particular kind of problems, this doesn't mean that if a problem is very hard for a quantum computer, is also very hard for a classical computer. And of course, for the encoding, process, there might be a large computational power demand for doing it. Or we may have a limited amount of signal messages that can be exchanged. Or we may be not so sure that actually these hard problems are cannot be tracked by quantum computer, because till now we don't know all the power that a quantum computer can give us. So we can have also another solution to our problem, which is basically what I'm going to present, which is, and I need to go back a bit and see again this simple cryptographic scenario, where now we have basically replaced this channel of prior key distribution with a quantum channel. What does it mean? This means that now we have the luxury of using quantum states in order to send the key kappa to both of the parties. And then they can, of course, use one-time pad, which I might explain a bit later, to encrypt and decrypt their messages. So what is the advantage of the use of quantum states? So first of all, the quantum states manifest this kind of basically they can be described by the Heisenberg's principle, where when we have an interaction and with a quantum state, this means that we perturb the system. So it's not like a classical interaction that by observing a particle or an object, we don't change its state. And now imagine that Alice is sending her signals to Bob, and there is someone, Eve, that can actually take the signals, make a copy, and resend this to Bob. If the states were classical states, then this could work for Eve perfectly. But now with the quantum states, assuming this interaction and perturbation assumption, Eve, by doing this, she cannot really copy perfectly the state. So she keeps one copy for herself, but is perturbed, is a noisy state, a noisy signal, and she sends back to Bob another noisy signal too. By this, Alice and Bob can track the eavesdropper, so they can really track if somebody heard their conversation. And this can be a real advantage, as we can see later. So in secret key distribution, we produce secret keys for the parties. In order, for example, to be used for the one-time pad. And we know that for the one-time pad, we need a random string, which will be the secret key. This should be shared by the parties. So both of them should have the same key. And this should be secret. So we should be sure that nobody has heard it. And of course, there are other requirements, like the length of a message should be as long as, the length of the key should be as long as the secret key. And this secret key should not be used again for any other methods, because then we can have some security problems. So in order to do that, Alice and Bob, the two parties, they exchange quantum states encoded with a random variable, and then Bob applies. So Alice is sending these encoded states to Bob, who applies measurements in order to decode them. In the middle, we assume that the eavesdropper controls the channel, so controls all the noise and any other property of the channel. By doing that, we have achieved the randomness step, let us say. Then Alice and Bob apply error correction between the two strings, because Alice has the encoded variable and Bob has the decoded variable through the measurements. So that we have now a shared string. But then, what about the secrecy? So by let's say that Alice and Bob signify some instances and of the encoded variable and decoded variable, and by them they can compare them. So they can basically trace the noise produced by the eavesdropper, how much the states were perturbed, basically. And by doing that, they can actually know the amount of noise, and then by using privacy amplification, which is some kind of compression, they can compress these strings in the correct amount, so as based on what they have calculated before, based on the noise, basically, so as to achieve smaller strings, but secret ones. So basically, this is the steps of the secret key distribution. And of course, afterwards, these secret random data strings, they are used as the keys for the previous scenario. So now I can say more about the quantum states and maybe explain more why we have this advantage of using them. So basically, in the kind of QKD that I study, we use signal states that are bosonic modes of light, which resemble a lot with energy field or electric and magnetic field of the electromagnetic field, basically. And they can be used really easily by the current technology, optical fibers and so on. They form non-orthogonal sets. I mean, this is the key element in order to do QKD. And basically, they can be described by continuous decrease of freedom. Like, for example, when we have a pendulum, we can describe it by its position and momentum every time. So in the same way, we describe these states. These states basically are described by the Wigner function dependent on these two parameters. And in the phase space, which is a two-dimensional space of these coordinates, this Wigner function resembles like a bump, as you can see here. I will be more specific now, and basically I want to talk a bit about the Gaussian distribution. So as you see here, we have a Gaussian distribution, and head variance is sigma. And we can see that this distribution expands in the infinity. So it can take all the values of the x-axis here, and the variance is sigma, as I said. So imagine this same picture, but in a two-dimensional space, where we have the quadratures, Q and P now. And we see basically on top of the Gaussian distribution. So we might have a circle. This expands to all the place here, but the variance can be defined by this circle. And the mean value basically can be defined by the center of the circle, which now has this distance x from the 0 point. Okay, so this basically is the description of a quantum state that I said you before. I tried to describe you before. And more specifically, these states that have this bell shape, they are called Gaussian states and can be described only by two parameters, their covariance matrix, or in a sense their variance, and their mean value. And they have also other mathematical properties that we can use in order to simplify later calculations, but this is not for this talk, basically. So what does it mean, non-orthogonal states now? So imagine that we can have a classical state. A classical state in this kind of description is just a point, while a quantum state can be described by all the points, but with a certain weight. All the points of this field here participate, but with a certain weight, such as to have the mean value in the center of the circle, for example, and the variance to be depicted by this by the circle on its own. So then, so this is the quantumness, the quantum characteristic of the quantum states, that they are not only described by points in this kind of in this kind of description, but by circles. So with another circle, another state, we can see also with this circle there is overlap. There is some overlap. So we cannot really distinguish between two states easily. While if we have the points, they are very, each one of the points is apart from the other. So keep that in mind, and I continue. So what we basically do, we use this kind of signals, and we on their mean value, we apply Gaussian modulation. This is an extra Gaussian modulation. And these signals are sent to Bob, and then Bob is measured through a quantum channel. And Bob is measuring and gets the variable y. There's also this classical channel that we use in order to exchange and compare the signals, as I said before. So as to do error correction and private amplification afterwards. This is the classical post-processing, apart from the quantum communication. Now, I haven't talked about what happens in the intermediate step. This is how we model basically the attack from Eve, from the eavesdropper. So it can be an attack that it is applied to every single state that we send, and Eve then is measuring her mode, because Eve she sends her mode, which interacts with this interaction U with the traveling mode. So we can have this picture where she every time measures the interaction mode, basically her copy from the traveling mode, right? Which is the basic attack we can imagine. Then there is the collective attack, where she basically gathers all the modes after interaction into a quantum memory. Quantum memory in general is very expensive, and but here, because we want to be sure that we have taken everything into account in terms of security, we give this power to Eve. And then she measures all the modes collectively, basically. And there's the strongest attack, of course, is that she interacts with every single state altogether with one interaction, and then she stores her modes and applies a collective measurement. This is a coherent attack, but through a mathematical procedure, usually in most cases, can be reduced to the collective attacks. So in a sense, proving the security for collective attacks, we can extend the security also for the case of coherent attacks. It turns out that this kind of attack, this kind of U, is a unitary, is a Gaussian interaction, which means that any Gaussian state that goes through, it actually turns out, when it gets out of this interaction, it is still a Gaussian state. But this allows us for simplifying the interaction to this picture, and further simplified it in the entangling chloride attack, where basically we have that Eve has two modes with where she induces thermal noise omega, and one mode is interacting with the traveling mode through a beam splitter, this can simulate basically the optical fibers. This is the current technology we use to communicate. So in the end, we can calculate basically two functions. One is the mutual information between the two variables, and the other is the Holevo bound between one of the variables and the eavesdropper. So the mutual information quantifies how much information, how much correlations there are between the parties. And the Holevo information quantifies how much correlation how much knowledge basically there is between one of the variables and the eavesdropper. So by taking the difference, we can actually calculate the secret key rate. So this is like how many secret key bits we can have, given that we have sent one signal state. This is the central benchmark that we use in order to quantify the security and also the performance of a protocol in terms of the distance, because this is the main problem currently, that we can achieve only only distances inside, for example, a city, but not between two cities or further. But we are still improving on doing that. And for example, we can plot this secret key rate and have results like this. I'm just showing this to you just to see like a part of the research how it is. So now, till now, I have spoken about sending classical information using quantum channels. But for a moment, this is like the final step of my talk, I just want to consider what could happen if we use quantum information and exchange quantum information between quantum channels, through quantum channels, sorry. Then we are going closer and closer to establishing the quantum internet, where QKD kind of security is already included in this in the quantum internet, which still is a project that that we may accomplish in the future, and a lot of people work nowadays towards this. We can use then quantum computers in a cloud, so everyone can have access to quantum computers, and also we can have extremely accurate coordination and synchronization between two places or two machines or whatever through clocks and sensors. This quantum internet assumption is using as a source the quantum property of entanglement, which is basically the maximal correlations that are allowed between two parties to establish from nature. It is also inherently private, these correlations, which means that when a party is correlated with another one, and at some point tries to be correlated with, these correlations cannot be shared with a third party, because if one of the parties tries to be correlated with a third party, then it stops to be correlated with the first one. However, this entanglement as a resource is a very sensitive resource, and this is because, as I said before, the quantum states cannot be copied, or they cannot be copied perfectly. So a lot of these kind of correlations can be lost very easily. And nowadays, researchers are searching for special technology for quantum repeaters, basically, in order to be able to implement this traveling of quantum information through quantum channels. This is more or less what I wanted to say, and I for your patience.
Thank you for sharing that today with us.
Thank you, that was great.
And does anyone have any questions? Please put them in the chat if you do. Give that a minute for if anyone asks anything.
Yeah.
Whilst we're waiting for that, I'll ask you the same question that we asked the previous speaker. What do you think is next in this line of?
I just talked about it in my last slide. This is what we want to achieve in the end, the quantum internet. where this basically I can talk a bit for this step, the cloud quantum computers, because maybe till 2035 there will be like a quantum computer that can be used, but this will be in a specific place somewhere in a room. And in order, for example, laboratories to be able to have access to this could be only done through sort of a quantum network, which is at least a part of the quantum internet idea, in a sense. But what these will give, apart from the computation part, that it will be faster to solve a problem, we can have what we, for example, imagine that we want to test a specific chemical on our DNA. And this could not be, instead of going to our lab and do all the stuff, we want to run a simulation first, which could be very difficult for a classical computer, but for a quantum computer it could be very easy. However, we do not want to share our DNA in the cloud, and of course we don't want to share this the structure of this chemical component or any other code that says how we are going to these two to interact. This should be a secret because, for example, another group can access our research and publish first results, for example. So this is the new thing that we can send to the quantum computer information, but also like the steps of our algorithm encrypted. The quantum computer will do everything, and the result we can only decrypt the result, and nobody else can really have access. Also in our code, which is nowadays this is not I mean a really easy concept to think, because at least I mean some of the functions that we use in our code, they will be nowadays they can be really known. I mean, in order for the computer to know what to do, right? But even the structure of the code can be something secret now by using this. This is what I wanted to add, basically. And this is called blind computing. If blind quantum computing, if someone wants to search for more information.
Great, thank you for sharing that today with us then. I think we haven't got any further questions, so we'll call it a day there. But yeah, thank you for joining us, and thanks for sharing that with us today.
Thanks a lot for the opportunity. Thank you.
So that's it for us today. We'll be back. I think we have a meetup plan for next month as well, so we should be back for that, which again will be online. So please join us for that again. And that's it from me.
See you all at the next meetup.